Hello everyone, welcome to the third installment of my capstone presentation. Today I'm going to be talking about feature engineering holistically, model development, and then model evaluation. So just as a reminder, there are 4 different cohorts that I'll be working on for my project. Today I'm going to be talking about running backs just in the interest of time. So feature engineering is where I'm going to start. Talk a little bit about scaling the data because some of the data is very, very different. And then PCA for dimensionality reduction, and then model development and evaluation. The next steps after that. So just as a reminder for some of the independent, some of the raw independent data, we have team performance, which is the player's team and how well that team is performing in multiple categories that I hypothesize to be important for the individuals to perform. Same thing for the opponent. So how well is the team that they're playing that week do in combating the offensive metrics? So how well can they stop the run, for example, and stop the pass? And then the weekly individual player performance comes from Kaggle. This is a data set which historically gives you, on a week-to-week basis, how well that individual player performed. So from that, we derived from features that I'm going to call pseudo time series data elements. And what these are is essentially going back in time to see how well the player performed the previous week, on average the last 2, and on average the last 3. So as you can see here, the first line of code essentially just goes back one row in the data set and collects that data for rushing yards. And then the other 2 just go to the previous 2 and previous 3 and calculate the mean. This is a really easy way of kind of deriving some of that data. And then for our target variable, you're essentially taking some of those other data elements, which we are creating pseudo time series data out of, and calculating the fantasy points by saying, rushing yards and receiving yards. For every 10 you get, that's a point, and then for a touchdown that you either receive or rush, that's a total of 6 points. So a 10-yard touchdown run is worth 7 points. So if you do well in these categories, your player is going to score a lot of points. Here's a look at some of the raw data from Pro Football Focus, our opponent efficiency metrics. Like I said, combating the offensive side of the ball, stopping the run, stopping the pass. These are this next section of the team efficiency metrics. So, can this team be a catalyst for that player to perform well? Can they block well? Can they, block well for both running and passing the ball? And then holistically, how well are they doing in running and receiving? Here's a look at some of our time series, pseudo time series data. This is the receiving yards, the first one being previous week, and then 2-week average and 3-week average. And here's our rushing yards, both previous 2-week average and 3-week average. You see there's some outliers there. There seems to be a player who rushed for almost 300 yards. And this is all the same data. I just wanted to wrap it around 0, normalize it, scale it a little bit, just so that I think it would be helpful. Or will be helpful in our model development. So it's all the same data. You can see those outliers are still there, but we went ahead and normalized it. So next, I wanted to point out some interesting correlation coefficients to you guys. This first section here is talking about some of the receiving features. The first 3 are the previous and 2-week and 3-week average for receiving targets. So how frequently does the quarterback throw at that running back? And then the next 3 are receiving yards. So as you can see, receiving targets seem to explain more of the variance in our target variable, which is interesting. This next session is all about running the ball. So the traditional way to score points as a running back is to have the quarterback hand you the ball and then you run with it. So this first section is rushing attempts. The first 3 are rushing attempts. The 3-week average accounting for 57% of the variance in our target variable. And then the final 3 being rushing yards. As you can see, the correlation coefficients for these are the highest, and these are traditionally the ways that you would run the ball. So the next key insight I wanted to point out, this is rushing and receiving touchdowns, receiving being the middle section. So, as you can see here by pointing out the first 2 sections, you want to target the players who touch the ball frequently, whether they're getting targets rushing the ball or receiving it. Those are the players that you want to target, as those are the ones that are kind of heavily involved in the game plan. Here's a visualization of rushing attempts on the x-axis and fantasy points. So it's kind of hard to visually show the importance of, or the kind of the relationship here without kind of sampling the data, but I wanted to show you this way because I wanted to loop in touchdowns. So once you kind of loop in touchdowns as a factor of color here, specifically just like a gradient, you can see those players in those top right corner are the ones, or the right side of the graph, but in the top right are the ones that are getting, you know, a lot of rushing attempts, scoring a lot of fantasy points, but also scoring a lot of touchdowns. So while, you know, touch frequency is really, really important, the touchdowns may be the reason you win your fantasy matchup. So those are the players you really want to target as well if you're looking for the top players. Example, this is Todd Gurley. While he's not playing great this year, historically he is the guy that gets a lot of volume and scores a lot of touchdowns. And then for my Ravens fans who get the reference, Lamar Jackson. Here's receiving targets, so less important, but again, wanted to show you this. It's kind of hard to see the relationship there without the touchdowns, but or once you loop in the touchdowns, you can see some key insights there. These players back again to the right side of the graph are the ones that are getting a lot of targets in the receiving game and, you know, scoring a lot of touchdowns, hopefully in the top right. Example of this is a guy like Alvin Kamara, who catches a lot of touchdowns but is a running back. So for PCA, I went ahead and took away some of the team and opponent performance metrics as they really weren't, I wasn't seeing much of a great correlation coefficient between those and our target variables, so I dropped them. So focusing mainly on the historical kind of longitudinal time series data. So we went ahead and scaled our data before sending it to our PCA, which we used 3 components, and the output of that being 3 components, 57%, explained variance in the first component, and then 20, and then 8. So model development and performance, fun part, went ahead and used grid search for, you know, optimizing parameters, and then our estimator is going to be a random forest regressor. So I used a cross-validation of three different samples, and then basically after doing the training and evaluating on the test, we got a mean absolute error of 3.9 fantasy points on the test set, which is pretty exciting, I think. You know, for running backs, like I said, there's a lot of variance there in terms of how well that position is going to play. So to get it within 4 points, it's pretty good. Final steps: disseminate the performance of the other 3 models to you guys. I think those will be really interesting, as those position groups are also really important. I wanted to test the performance of the gradient boosting regressor as well on those 3 different cohorts, and then I wanted to append the weather data. I actually had to purchase it, and some of the formatting has been kind of difficult, but I do want to and plan on kind of including that as well. So we'll hopefully do that in the final presentation. So thank you guys so much. I appreciate your time and look forward to reviewing your presentations.